Hey guys, here's a video to kind of walk you through how to find horizontal asymptotes. And the idea here is we're trying to figure out what is happening to the graph as x goes to either plus or minus infinity. So essentially, we're taking a limit of the function and we're trying to determine if, in fact, we get a value there. We also want to check the other side. We want to check what happens as x goes to negative infinity, and also determine if we get a value. Now, they may not be the same value, but we still need to kind of check both directions to see. So sometimes this is called end behavior, but we're just gonna kind of refer to it as these are horizontal asymptotes. And we've actually dealt with vertical asymptotes before. We used to try to figure out if the denominator was zero was a potential, if there wasn't already a factor that canceled it out, but we'll do that in a different video. So for this video, we're just gonna focus on horizontal. So what's happening to the function as x gets really, really big or really, really small? In order to be able to do this, though, we have to agree on one fundamental principle, and that's this. So check this out. Suppose I wanted to figure out what the limit as x approaches infinity was for 1 over x. So think about that for a second. If x is approaching infinity, so bigger and bigger numbers for x, what do you suppose is happening to the ratio of 1 divided by that number? All right, pause the video and think about it and come up with your own answer and hit play when you're ready. All right, so if x is approaching infinity, so say 10, 1 over 10 is 1/10. 1 over 100 is 1/100th. That's smaller. 1 over 1,000 is 1/1000th. And the numbers are getting smaller and smaller. They're approaching 0. So the limit as x approaches infinity of 1 over x is 0. 1 divided by like a gazillion is 0.00000, however many zeros gazillion has, if that's even a word. And you're going to get a super small number, really close to 0. What about going at it from the other direction? As x approaches negative infinity for that? Well, again, negative 10, that's negative 1/10. Negative 100, that's negative 1/100th. It's still getting smaller and smaller, but it's coming at the 0 from the left-hand side instead. So it's still going to approach 0. Graph it. Graph 1 over x. 1 divided by x. There's a little glare there. There we go. As x approaches infinity, which is this way, look how close to the axis this graph already gets. And this is only 0 to 10. Right? 1 over 1, 1 over 2, 1 over 3, 1 over 4, 1 over 5, 1 over 8, you can't even see. It's that close. If I zoom in on the window for my y values, let's just go negative 1 to 1. You can see it a little better, but it's still getting really tight to the x-axis because as x goes to infinity, this graph is approaching 0. As x goes to negative infinity, this graph is approaching 0. The limit as x approaches either plus or minus infinity for 1 over x is 0. This is a key fact that's going to help us, this is going to help us figure out our horizontal asymptotes going forward. So this actual equation, if f of x equals 1 over x, we have a horizontal asymptote at y equals 0. That's how you would say it. Of course, this has a vertical asymptote at x equals 0 because, again, if you plug in 0 here, which you can't, you're going to get undefined. You're going to get an infinite limit, which is going to be our vertical asymptote, which, of course, you can see in the graph as well. Or maybe you can't see because of the glare there, but there, right here, you have your vertical asymptote. But again, we'll talk about that more in detail in a different video. For now, we're just looking at what happens as x approaches plus or minus infinity. So with this in mind, let's look at our first example. Suppose we have 3x plus 5 over x minus 4. Okay, so again, if your instincts are to kind of look down here and figure out when this is 0 and see what happens, that's great. That'll help us with our vertical asymptotes. But for horizontal, I have to basically answer this question every time. Is there a limit as x goes to infinity? Is there a limit as x goes to negative infinity? So let's check. The limit as x goes to infinity of 3x plus 5 over x minus 4 is what we're looking for. And the trick here is we're going to try to simplify this fraction a little bit to be able to figure this out. Right now, I don't know what it is without doing a little bit of work. So here's the key step. What is the highest power of x in the denominator? That's the question you're going to hear me ask you every time we do one of these problems. What is the highest power of x in the denominator? In this case, it's x to the first. So you're going to use that and you're going to divide the numerator and denominator by that value. So what does that look like? That's going to look like this. I'm going to take the 3x plus 5 and I'm going to divide by x. I'm going to take the x minus 4 and I'm going to divide by x. I'm doing the same thing to the numerator that I'm doing to the denominator, so it's okay. This is kind of like multiplying by, 2 over 2, if you're going to do like a common denominator type thing. In this case, I'm really multiplying by 1 over x and 1 over x. And that x isn't always x. It could be x squared, it could be x cubed, it could be x to the anything, depending on what the highest power is. In this case, it's a relatively simple one. It's just x to the first. But just keep that in mind that this may change. Now we simplify. So this becomes the limit as x goes to infinity of 3x over x plus 5 over x all over x minus 4 over x. I'm just breaking out this denominator for each piece one at a time. And the reason for that is, well, one, we can simplify this a little further, but hopefully your eyes might be drawn over here. There's a connection with the limit we just found with 1 over x to what we're doing down here. So keep that in mind. A little spoiler alert there. So let's do one more step to simplify, and then I'll show you how that works. So I'm still doing the positive infinity. We'll do negative infinity in a moment. So positive infinity, I'm still going to just simplify. So this becomes 3, right? Those x's cancel. Plus, now watch this, 5 times 1 over x. That's the same as 5 over x, right? So I'm not always going to write it this way. I'm just trying to show you that it's the same thing. So I really want you to see the 1 over x part. Over x is 1 minus 4 times 1 over x. So I actually haven't done the limit yet. All I've done is the algebra to simplify this, ratio as many times as I can to make it look like something that I feel I know how to do. I know how to do this. I know how to do the limit for 1 over x because we just talked about it. Anytime you're doing the limit as x goes to plus or minus infinity for 1 over x, you're going to get 0 every time. So that means this part is all going to 0 as I apply that limit. 5 times 0 is still 0. 4 times 0 is still 0. So look what you're left with. This is just a 3, and this is just a 1. There's no x there. So the value of this limit is simply going to be 3 plus 0 over 1 minus 0, which of course is simply 3. We're going to have a horizontal asymptote at y equals 3. That's how that works. And I'll show you the picture in a moment. What if this was negative infinity? What if I change this up? Let me just sneak. I'm going to cheat. Instead of rewriting the whole thing over again, I'm just going to cheat. I'm going to put negative infinity. Negative infinity. Nothing's changing here. I'm just changing the limit. Negative infinity. What's the limit as x goes to negative infinity for 1 over x? Still 0. It's not changing. It's still 0. It's still 0. It's still 3 divided by 1. Now you might ask, well, why do you have to check both? Well, there are some trickier problems where you actually might get different answers. But in this case, there's nothing that's going to affect that value approaching 3 over 1, regardless of which direction you're going. Let's take a look at the picture. So this is 3x. I got to use parentheses so I don't get it messed up, the order of operations here. So 3x plus 5 divided by x minus 4. Do a regular window. Oops. Do a regular window. And see what we get. I'll try to get the glare out of there. Check it out. As x approaches negative infinity, this graph is flattening out. As x approaches positive infinity, it's a little hard to see because it's spread out a little bit. So let me change my window. Let's actually put really big numbers in here. Negative, yeah, I guess I could do 1,000. Why not? To 1,000. Check it out. Now that just looks like 3, doesn't it? Right? As x approaches negative infinity, this almost looks like a horizontal line all on its own. And on this side, as x approaches positive infinity, this looks like a horizontal line at 3. Right? So the idea here is the horizontal asymptote. This graph is approaching 3 all the way as x goes to infinity and approaching 3 all the way as x approaches negative infinity. Okay? And that's the idea behind horizontal asymptotes. So your basic strategy, I'll do another video with a more complicated example, and then I'll do another video with the vertical asymptotes to help with that part. That should be mostly review though, but this is the new stuff. All right, good luck, and be sure and let me know if you have any questions. Thanks.